for coming and watching another Scientist's Warning program. I'm your host, Stuart Scott, along with Regina Valdez, and we're coming to you live from Madrid, Spain, COP25, the 25th annual ritual of kicking the can down the road. Here's a contact address if you'd like to get in touch with us, and we'll present this again at the end. Today's guest with us, Dr. William Moomaw. He's Emeritus Professor of International Environmental Policy at the Fletcher School of Tufts University. He's also board chair for the Woods Hole Research Center, and he's lead author in 5 of the IPCC reports, as well as co-author, one of 5 co-authors of the World Scientists' Warning of a Climate Emergency, published in November of this year in Bioscience. This is a very, very important paper, and Dr. Moomaw's here today. May I call you Bill?
Yes, please do.
To tell us about the paper and its contents. And today's program we're calling Humanity's Mortality Moment.
Thank you very much, Stuart. I want to talk to you about responding to the climate emergency with natural solutions. This is a front page of our article that was just referred to, which has had an amazing response. And in it, we state that scientists have a moral obligation to let the public know what's actually happening. And we've joined together in looking at all of the data and information and have decided that it is necessary to declare this a climate emergency. So here are the things we have to do. We have to obviously first transform our economy, get rid of fossil fuels and other things that we're burning, putting into the atmosphere, biofuels and various things.
And get rid of the subsidies first.
Absolutely, get rid of the subsidies first. It's unbelievable that we're paying people to put more carbon into the atmosphere, country after country after country. We need to reduce the black carbon that comes from some of that combustion, diesels, coal, burning wood for electricity, and methane, nitrous oxide from agriculture, and some industrial chemicals. We need to protect the natural systems that are already removing well more than half of what we put in every year of carbon dioxide, and increase the capacity of natural systems to remove carbon dioxide. Our food habits for the whole world have a profound effect in terms of emissions. They emit carbon dioxide, they emit nitrous oxide from fertilizer, they emit methane from primarily animal husbandry. And we need to shift our food and diet away from animal and towards plant-based foods.
No more Big Macs?
Well, they are now have Impossible Burgers and all kinds of things made from plant foods that are selling really well, apparently, at least in the United States, which is where we are the king of Whoppers when it comes to hamburgers.
And we just have to consume less meat products to start with.
That's right. That's right. We have an economy that is geared to, it could not be better designed to emit carbon dioxide and other gases into the atmosphere than it is. I mean, it's just amazing how we have become so reliant on fossil fuels. And so we need to reduce the activities that release those emissions and these heat-trapping gases and create a carbon-free economy.
It's the economy, our current mainstream growth economic system, that is causing our doom. It's incenting us to consume the planet more and more quickly. It's an insane system, but they can't get off it, because if they stop that exponential growth, the Ponzi scheme falls apart.
It is a bit of a Ponzi scheme, and it takes all kinds of interventions to keep it going from central banks and so forth. So it is not just a market system running itself like it was promised to be way back in the 18th century. And it needs a lot of work to keep it running. And then finally, there's the human population. We're adding 80 million people a year to the planet's human population. There are economists that will tell us that we have to keep having more population growth to keep the economy going. I find it absolutely bizarre that my role in society is to keep the economy going, and it's women's role in the society to keep having babies to keep the economy going. I find that just an extraordinarily bizarre notion of what is most important. Does the economy serve us, or do we serve the economy? And so one of the things we have to do is to do this in a way that will keep society intact. And one of the things we can do is to provide education for girls all over the world, and provide women and girls with information about managing their own fertility. So why would 11,000 scientists agree to declare a climate emergency? Being a scientist, I can tell you, we're a pretty contentious lot. We argue a lot about the science. Did you measure that right? Did you do this? To get 11 scientists to agree is really remarkable. To get 11,000 scientists to agree is just extraordinary.
So I can use that old New York joke, you get 11 scientists together, you get 13 opinions?
That's right, at least 13 opinions. So we use the term emergency deliberately. We felt that terms like crisis and disaster are not very helpful. They simply leave you feeling depressed because there's nothing you can do about it. There's not even a possibility suggested in those terms. But emergency means something something dangerous is about to happen, and you can work to prevent it, or you're going to have to respond to a mess afterwards. Just like you can prevent an automobile accident, or you can deal with it after the crash. And we want to try to do it before rather than after. So we are, as scientists have improved their capacity and had more time to gather more information about what's happening in the world, we've come to recognize that abrupt and irreversible changes are coming at lower and lower increases in temperature. So these 4 bars here represent the estimates in 4 Intergovernmental Panel on Climate Change reports beginning in 2001. Every 6 years, one of these reports comes out. And back in 2001, and I was a coordinating lead author of one of the chapters there about emissions from industry and transportation and everything. And we thought that maybe somewhere around 5 degrees Celsius, we would start seeing irreversible changes. That's how little we knew, because by then it wasn't obvious that Greenland was melting. It wasn't obvious that Antarctica was melting. We were just beginning to see the melting of the Arctic sea ice. And then 5 years later, it looked like it might be somewhere between, maybe a little below 5 degrees. And then 6 years later, it looked like it might be around 3 or 4 degrees. The report that came out just a year ago, it's between 1.5 and 2 degrees. Everybody says, what's the difference between 1.5 and 2 degrees? 1.5 and 2 degrees difference is we get a lot more irreversible changes at 2 degrees.
I just have a question to interject here, and that is, I've heard a lot of people who are not really cognizant of the science poo-poo the issue of climate change by saying scientists keep changing their mind. They don't know what they're talking about. They're exaggerating. How do you address this type of charge when it has gone from we need to keep it below at 5 degrees to 1.5?
Well, it's a good question. I mean, the thing is that a lot of people have the attitude, my opinion is as good as yours. But the famous statement is, you can choose your opinions, but you can't choose your facts. Scientists don't make up facts, and therefore they don't claim things that they don't know about. And back in that earlier time, we just didn't know. With the information we had, 5 degrees looked like what it was. And I'll have to say this, I cannot think of a single thing that has been studied in science about climate change that has come to the conclusion that it's not going to be as bad as we thought it was yesterday. It just keeps getting worse and worse as we learn more and more, because things are getting worse. That is, this is not just some creeping problem that will be future generations. It is accelerating every single day from what it was before. So let's just take a quick look here that there are changes in the world, and many of them are becoming irreversible. And this is just a map that was put together, and it just shows the different things. You know, the thawing of the permafrost. You know, if the permafrost thaws, this is basically like the carbon in the soils is like frozen meat in your freezer. What happens when the electricity goes off and that meat thaws? It rots. And that means bacteria are chewing on it. And it's the same thing is happening. It's not meat that's in permafrost. It's basically organic carbon in soils. But the same thing happens. In the liquid water, the bugs wake up and they're able to start devouring it, and they start exhaling methane and carbon dioxide. The melting of ice in Antarctica, the melting of ice in Greenland, the rising of sea level, all of those things are on this map. So climate tipping points are too risky to bet against. We don't know where they are. We don't know what all of them are, but there are enough of them out there. Oh, by the way, I might just say, you could say if any one of these things that's on this map, oh, it's just a coincidence. But the fact that all of them are happening and they're all traceable to a changed climate makes it pretty certain that this is really caused by climate change. And so the growing, this is a direct quote from this paper, the growing threat of abrupt and irreversible climate changes must compel political and economic action on emissions. There is no scientific action. There is no magic bullet. We have to change and respond to this in our economy and in our political system, and that's supposedly what we're here in Madrid for. Question, are we running out of time? Well, boom. This is a remarkable graphic that was put together. And what it shows is the historic trend, that's the black line, and then the various colored wedges going from darker red to lighter pink are really the following situations. The first is the current policies. We're somewhere in that range, just doing what we're doing now, business as usual. But didn't we have Paris? We did have Paris. This is what the commitments will get us. It's a little bit better, but it's nowhere near enough. Nowhere near enough. But in Paris, we said, that's what countries did in their nationally determined contributions. But they said we should not get more than 2 degrees. We have to be somewhere in that wedge going down to stay within 2 degrees, and to stay within, make all efforts to stay within 1.5 degrees, we have to go down in that really steeply dropping one.
And I'm sorry, I'm going to put a little more time pressure on you to finish up, but the 1.5 and the 2 degree goals, the guys and girls over there keep moving the goalposts. They should be 1750, and if you go from the 1750 baseline, then we're already at 1.5 degrees.
Right.
But they moved it to 1850 because that's when et cetera. They had reasons.
That's right. It's
convenience.
That's right. Well, and that's when the thermometer record starts. And it's a little difficult to estimate 1750, but that's no reason to ignore it. It was cooler in 1750 than it was in 1850.
And then some countries came in and said, we're going to use a 2005 baseline.
That's right.
Because we can.
That's right. In a bleak report that just came out a little over a week ago by the UN, this remarkable statement in there, we need to catch up on the years in which we procrastinated, a top UN official said. Global greenhouse gas emissions must begin falling by 7.6% each year beginning in 2020, a rate currently nowhere in sight to meet the most ambitious aims of the Paris Climate Accord. In 2005, I wrote a paper doing an analysis. It was called The 2% Solution. If beginning in 2005, we had reduced our emissions by 2% a year, by 2050, we would, and assuming that we didn't destroy nature that's sucking up carbon, that we would have stabilized the climate and the temperature at sort of reasonable levels around 350 parts per million or something like that. So we've wasted that opportunity, and to add, I guess, salt in the wound is the term that people use. The World Meteorological Organization just announced, no big surprise, that despite all the things that we say we're doing, carbon dioxide emissions reached a new high, and so did a lot of other gases, methane and other heat-trapping gases. So we need to catch up on the years in which we procrastinated. That's a message for the negotiators who are here in Madrid right now. That is a very untypical statement from a UN agency. That is a harsh statement in diplomatic terms, but it's very much on target.
Does that mean, does that statement indicate that not only do we need to meet net zero, but actually negative, we need to draw down right away?
Yes, thank you. Let me just say, here's the 1.5 degree report, and let me just put it in the context of this, the answer to your question. So this came out just a little over a year ago, and here's what it says. To keep temperatures from rising above the 1.5 degrees, global net anthropogenic carbon dioxide emissions must decline by about 45% from below 2010 levels by 2030, reaching net zero around 2050. All right, so now we're on the verge of 2020. That means we have just 11 years till we get, we go through 2000 and then, or 2020 and then up to 2030. 45%. That's why we have to go down by 7.6% a year.
Oh, but it's only 2019. I got 20 years. I can do it.
Yes. The trouble is people think, oh, let's wait till 2030 and then let's go. Let's go on it. When I talk to students, I said, that's the equivalent of students sitting in lectures, not doing the assignments, and then staying up all the night before to do the final exam. That usually does not work out well. It doesn't work out for students, it doesn't work out for diplomats, and it doesn't work out for the planet. And so here's the point that people really need to understand. We must simultaneously reduce combustion emissions and all other sources of emissions of carbon dioxide, and from methane, and from all these other heat-trapping gases. And simultaneously, we must increase the removal of atmospheric carbon dioxide by nature-based solutions. It's not either or, it's both and. And this business net emissions, what that means is the difference between what we put in and what nature takes out. A term that's commonly used, you'll hear it, you'll see it on the signs around here, carbon neutral. Oh, that sounds so good. That's not a scientific term. Carbon neutral is not the same as zero carbon. Carbon neutral means someone else at some other time, at some other place, removes carbon so I can emit more.
Maybe, because this is an accounting system that they came up with in there to allow wealthy countries to pollute more while they supposedly plant more trees in Indonesia, which are probably harvested 5 or 10 years down the road.
That's right. I mean, it's not only Indonesia. It's happening in the United States and it's happening in Europe. So, how do we remove more carbon dioxide from the atmosphere? Well, trees grow. I love the way that comes up like that. That's the way trees grow. They go from the bottom up. And you see a large tree on the left, and you see a skinny tree on the right. Which tree has the most carbon in it? Half of the weight of wood is carbon. All right, the big one, obviously. Which tree absorbs more carbon dioxide every year? The big one. The foresters will tell you, we've got to get rid of those big trees. They're about to keel over and emit carbon dioxide. The one you see there is about 160 years old. It's in where I live, Massachusetts. It's the tallest tree in the whole northeastern United States. It's something in the neighborhood of 53 meters high. It's pretty good size. That's only half the height of the redwoods in California, by the way. But it's a big tree. These trees are remnants of what was once an entire forest like that. We just have remnants, but we have them. And so there's studies now showing that we have been managing our forests in such a way that if we manage them differently, they could absorb twice as much carbon dioxide as they already do now. Remember, forests and wetlands and the oceans are currently removing more than half of what we put in every year. That's amazing. That's really nice to have friends like that. We would really be literally beyond hot water because the seas would have risen and the temperatures would be much warmer if it weren't for nature taking this carbon dioxide out.
But wait, I have a question because
Okay.
according to our president in the United States, President Trump allowing all these trees to grow so big and tall is causing forest fires and burning down the state of California.
Yes, actually, it's the cutting down of trees that causes forest fires. You find that there's very few forest fires in old forests with big trees. How many of you have ever made a campfire or lit a fire in a fireplace? Have you ever put a match to a big log? It doesn't burn. What do? You get little sticks. Little sticks burn. The fires in California are almost all in areas that have been cut over by loggers and have smaller trees coming back. And if you look at the photos of Paradise, California, which was decimated by fire, there are still tall green trees standing in the ashes and ruins of the buildings. So it's not the big trees that are causing the problem. So what should we do? Well, if we were to allow more trees to get to be big trees and older trees, we would not only reduce forest fires, we would store much more carbon. And the process for that, pro-forestation management, allows trees to reach their biological potential for carbon storage.
I haven't heard that word before. Where did that word proforestation come from?
Guilty. When we realized what the great potential for nature was to let existing forests grow, we realized there was a word for planting trees where none grew, afforestation, a word for planting trees where forests had been cut down, reforestation. We talked about restoration to solve deforestation, but there was no word that described this in less than 4 paragraphs. And so, to be honest with you, I went to Google and I Googled prefixes, and I got meta and all these words and everything, and I hit on pro. And so I talked to my co-authors, and we did a very scientific study by sharing with about a dozen of our friends and said, what do you think of this? And they said, it sounds good. Well, this paper has now been viewed over 16,000 times since it was published in June. It's really a concept that people recognize, and they are delighted to have a word for it. And here's something from a colleague of mine who is actually at a school of forestry. She's a forest ecologist, Beverly Law, one of the best of the business. She says, remember, carbon in forests and soils is carbon, not in the atmosphere, right? And so let me just give you a quick little instruction here on how this works. So this is looking at how many tons of carbon there are in an acre of white pines in a temperate forest. I'm deliberately doing temperate forest because we are in Europe, which is a temperate forest zone, and I live in the United States. We keep pointing to tropical forests. They're hugely important because they have a lot of carbon stored, but they're actually not growing that fast. The old forests are growing relatively slowly, and a lot of deforestation is going on. Forests in the temperate zones have been kept young so long, they have the potential to grow a lot in the coming years. So let's just take a look here. So this is just showing the amounts of carbon on an acre. I'm sorry, this was a US study, so that's 4/10 of a hectare. How many tons are in 4/10 of a hectare? And in 50-year increments. These are actual forests, actual measurements. This is not a model. All right, so why is the term carbon neutral not a good term? Well, we talk about sustainable forestry, meaning we cut down a forest. So we have a forest that has 22 tons in it, right? And at 50 years, we cut it down, and then we are so responsible that we either replant a forest or we plant a replacement forest, and it grows back in 50 years. And what happens then is, the red line shows, we have exactly what we had 50 years before, 22 tons. What would happen if we had let that forest continue growing, and we go and we find a 100-year-old forest of white pines, and it would have had 47 tons? All right, well, let's repeat this another round. We cut it down after it's grown back to its 22 tons, and we let it grow back, and we're back at 22 tons at 150 years. What would have happened if we'd allowed the original 22 tons to keep growing? It would be 76 tons. Remember, carbon that's in trees in a forest is carbon that's not in the atmosphere. Now, there are people who will tell you we can replace coal with wood, and Europe is doing this. More than half of all the renewable energy in Europe is burning something, burning wood, burning liquid fuels that come from plants. This is subsidized. It's not economically viable. It is leading to the deforestation of vast areas of the United States.
Hey, but it makes me money now.
Yes, right. That's right. It's in the United States and Canada. It's being shipped over here to Europe. The British are paying something like $800 million a year for a single power plant to replace coal with wood. Burning wood puts out more carbon dioxide per unit of electricity produced than coal does. That's not good. And we have foregone this possibility of really getting more removal rates. So
is it the size of the tree or the age of the tree? And if so, what about fast growth trees?
right. It's the size of the tree that has how much carbon is stored. The type of tree determines how rapidly it gets there. So different trees do grow more rapidly, but we could get smart on this and say, well, only plant the fastest growing trees. No, it turns out that a forest of mixed species sequesters carbon more rapidly than a monoculture, which is what a lot of tree plantations are. It's just one tree for one purpose, and it turns out that all of the biodiversity of bacteria in the soils, of fungi in the soils, of pollinator birds, pollinator insects, pollinator bats, all make that forest grow much faster. So the takeaway message is reduce emissions of heat-trapping gases immediately, as anything you can do, any change in behavior. Protect more of our existing forests and let them grow. We've got to set aside some of our forests and say, let them grow. And if we do that, here's a forest, a picture of a forest in the Northeast US, and you see those little trees? Those are about to become big trees over the next 50 years, but they will be adding a lot starting tomorrow morning. Thank you.
We wish to thank the International Society for Ecological Economics, the Tzu-Chi Buddhist Aid Foundation, and the Interfaith Center for Sustainable Development for helping to make this program possible. Thank you for watching Scientist Warning. This has been co-hosted by Stuart Scott and me, Regina Valdez. Here again is our email, as promised at the beginning of our show, coming to you live from COP25 in Madrid, Spain.